We have here a 5.7 liter Mercruiser engine with a crack block. It's an internal crack. We don't know where it is, but we know it's internal because we have water in the oil. We made several tests, but in the end we put 5 quarts of oil in the engine, ran it an hour, and it came out looking like this. This is set separating for a week now, and you can see there's just a tiny bit of oil on the top. The rest of it is just a little bit darker than milk. We started with 5 quarts, we came out with 6.5 quarts, so we know that the water is getting into the oil. We'd like to use this K&W block seal, but the problem is this is a boat engine, not a car engine. We spoke to these people, and turns out that what this stuff needs to work in a car engine, it needs to circulate through the engine, it needs to get up to about 160 degrees Fahrenheit, and it needs a little bit of pressure to push it through the crack so that the pressure pushes it through the crack. Oxygen on the other side begins to seal it. You drain the coolant system after 20 to 30 minutes, and then oxygen on the other side for about 24 hours finishes the cure. The problem is, in a boat engine, we don't have a closed system. What happens in the boat engine is that there's a pump in the outdrive, a small rubber pump. It pumps water up to the engine, comes in here. It goes into this tube, into the water pump. From the water pump it goes through the engine. The thermostat is under this housing right here. And the thermostat lets it out through these 2 tubes. A little bit of fresh raw water mixes with this. And on this side, it goes through the exhaust manifold to cool it, and then out. And then on the other side, through another tube, and the same thing. So we have a couple of problems. The first problem is that there is a small water pump in the outdrive. It's a piece of rubber, and it has to have water to lubricate it. If you run this pump, run the engine with this running without water, it'll burn it up very quickly. So the typical way to do that is to put what we call earmuffs on the outdrive and run water through the normal outdrive pickup, and that's how you normally get water into the engine when it's not in the water. So we still need to do that because the engine will be running, and we need to keep that little impeller cool. Also, that impeller is what drives the water up into the engine and out the exhaust manifold. We need to keep those 2 cool. So we need that circuit intact. But we need a closed circuit running through the engine. If we just connect the in and the out and let it run in a circle, the problem is it has to run 20 or 30 minutes and the engine will most assuredly overheat. So how do we fix that? First thing, we made a trip to the local junkyard and got a radiator. We just picked one out of a large truck, so it was a large engine to make sure it was big enough, and picked the easiest one to get out. Basically a truck that had already been scavenged quite a bit. So we're going to put the water in the top hole on the upper left and come out the bottom right. So in order to do that, we need to take the input water that's coming from the outdrive and let it go into both this hose and this hose so that it goes to the exhaust manifolds on both sides to keep them cool. And then we need to, this is the one that goes to the water pump, so when it comes out of the radiator, it needs to go into this tube and into the water pipe. And then it comes out of the engine through these 2. So we'll plug one of them and take the other one and put that into the radiator. So it'll come, one of these will be plugged, will come out hot into the radiator, out of the radiator, and into this hose, cooled, down to the water pump. So that means we're going to have to plug this one too. So we're going to have to plug 2 of these holes. Actually 3. The input, because the raw water is going to be going to these 2 hoses. This one, because we're going to be coming out of the radiator into this hose. And this one, because this will be connected to that one and will be opened. The other one, of course, will be going into the radiator, so we'll have a hose on that. So there's a lot of plumbing involved here, and we'll show you what we came up with there. So we said we had 3 holes to plug. The big one I'm going to plug with this 1.5 inch diameter pipe cap that I think I got this one at Home Depot. The little ones I had trouble with. The little ones we're going to plug with crutch tips. That's what these are. Two sizes, because there were two different sizes. Just chair, sometimes they're called chair tips, or anti-skid tips. I've always called them crutch tips. And then these parts, we got these at Tractor Supply in their plumbing section. This T is going to be used to put the input, the raw water input, to the two exhaust manifolds. And these two are going to adapt. We have an inch and inch and a half diameter tubing we have to add to this puzzle, and these are different diameters on either side, so that's going to help us adapt the sizes of tubes. The thing we're going to do is connect the water input coming up from the outdrive and the impeller down there to the two output hoses which cool the exhaust manifolds and take all of the water right out the back. So we're going to take those off. We had a little trouble with that one. It actually came apart. The screw came out. That's okay. We can fix that later. Usually I find you have to break the seal a little bit there before they're easy to slide off. Well, they're never easy to slide off. Okay. Those are the two outputs. This is the input. Well, it's raw water coming up from the outdrive. So that is what that's going to look like. We'll put clamps on that and finish it up in a little bit. Okay, I got this clamp fixed and put back on, this clamp on, and I remembered that the K&W block seal, if I can find it there, the K&W block seal, the instructions on the back tell you to do all of this without the thermostat in place. The thermostat is under here. So before we can go any further, and I get a bunch of hoses routed around here, I'm going to take the thermostat out. We'll just set that aside. Turn this over. And to make it a little easier, we'll just go ahead. This has to come off anyway. This is the hose that goes down to the water pump, engine-driven water pump. Get a little easier if we take these sensor wires off. Turn to the shop and put it in the vise, like this. And about the only way to get that little plastic thing out, it's a plastic piece that holds the thermostat in, is to put something here so that you can get above the plastic and then pry it out. And so I did that, and I did break the little piece that was here. There was a little piece that came down here, so I'll have to replace that. That allows us to get to the thermostat, and I pulled it out, and I did that before. There's also, of course, a little gasket underneath that I pulled out. Scrape this out a little bit. I'll leave it like that because you're supposed to run it without the thermostat in it. And if this works and fixes the leak, then I'll have to find a new one of these, and I'll put in a new thermostat as well. Might as well when we're this far into it. I'm going to use the old gasket. No sense in wasting a new gasket. We'll put the new one in after we finish this process. So we're just going to put that back in. Okay, we'll plug these sensors back up so that we can use the gauges on the dash later on. And the next thing we're going to do is plug the portions of this that we know since we're going to put the water directly into the water pump, we need to plug where that normally comes from. And we're going to use one of these, but not the other, so we're going to plug this one up with a crutch tip. I think this clamp will work okay. Those are nice and tight. Okay, and now I think we can, again, this is the water, the raw water inlet that comes from the outdrive, outside the boat. And we're going to be putting that directly into the exhaust manifolds to keep them cold, or cooled anyway, or at least to prevent them from overheating. I'm going to need a clamp on that though, aren't I? Oh, there's already one there. It's way down here. Okay, there it is. This normally is here. I'm going to move it to there. And tighten the clamp. Plugging this one just like we plugged that one. This is the radiator I showed earlier that I pulled out of a truck at the junkyard, but I did leave the hose on the output, and it's down here, so all I need to do is connect those two together. The output of the radiator will be going into the water pump. So here is one of the parts I showed earlier I got from Tractor Supply. It works pretty well, fits very well into this hose, which is again the one that goes down into the water pump, and also fits okay into the hose that came on the radiator. It's not a real good fit, but it's good enough. So I'll press those on and get the clamps put together. So I have those clamps tightened. It's not a great fit, but I think it's good enough. If it leaks a little bit, that's okay. And the last thing we need to do is get the hot water coming out of the engine into the top of the radiator. I took a little coaxing, but I finally got these hoses on. This vinyl hose here is 1 inch. It's a little bit smaller than the pipe here. And then over on our radiator, the same thing. This is reinforced vinyl, but it was a little small as well. So I put those in a bowl of boiling water and got them soft and coaxed them to go over. And now I just put some clamps on them. I've added now a little pump. This pump is it's dumping into oil jug and connected to the it's screwed on top of the dipstick hole, the oil. So I'm pumping out all of the old oil and also water that has leaked from the crack into the oil sump. I need to get all that out before we put oil in it. And then we're going to make this last connection from the hot water coming out of the engine to the into the radiator. We're going to make that connection next. So again, the last of the connectors that I bought at Tractor Supply. This one goes in here very nicely. This one will fit in here very nicely. Well, maybe not so nicely, but we'll make it work. I'm sure the more astute mechanics among you have noticed that I have this radiator in here actually upside down, and that's true. That's because in my haste to get a radiator out of the boneyard before they closed at 5, I ended up picking up one that did not have a plug in the drain hole, so I have an opening here. So I put it on the top so that it has a less likelihood to leak. So I put a bolt in the hole. I drove it in far enough that hopefully it'll block off the area where it normally comes out that hose, but I also put a clamp on the hose and a bolt on the other end and a clamp. So hopefully that'll be good enough to seal it up, at least good enough to run 30 minutes or so. Well, it's come time to fill the engine with water. Since it can't get water the normal way, we're going to have to put it in through the radiator. Hopefully this works. Well, the particular radiator I picked did not have the pressure relief cap on the radiator like most cars and trucks today. It's on the recovery tank. And I wish I'd picked one with it on the radiator. It would have been a little easier, but I didn't want to have all of the recovery tank and its tubing in the system, so I just cut it off. And I forgot to plug that hole, so water was coming out. So now I have a bolt and a clamp on the hose that used to go to the recovery tank. I think now we have a sealed system, and we'll put some more water in it. So now we have the hose back on the earmuffs. We're ready to turn on the water, which will give us water across the exhaust manifolds. I'm going to turn this on, go start the engine, and see if we have any leaks. So we have the engine running, and it looks like we have water circulating through the engine. You can see it in the clear hose that we have here. That's what we wanted to see. We'll run it a little bit longer and see if we have any leaks anywhere. Then we'll shut it off. It's not really necessary as a part of what we're doing here, but I decided that since I have the system closed, it'd be a good time to go ahead and clean the system, much as you would clean the coolant system of a car. It's easy, you drain it, you put the cleaner in there and you cycle it through the engine, but that's difficult in an open system, almost impossible in an open system ring, because it just would go right out the back and you can't recirculate it. So since I can recirculate it now, I'm going to do that. Now, I bought some that's a little more aggressive. It works in only about 10 minutes because the normal flush, most of the flushes that you buy need to run an hour or so. And if I ran it an hour or so, I'd get another 1.5 quarts of oil in my oil. I'm sorry, water in my oil. Another 1.5 quarts of water in my oil, and I don't want to do that. So I bought one that's more aggressive and only runs about 10 minutes. So we're going to take this apart and let some of the water out so that we can have room for the gallon of radiator cleaner, cooling system cleaner. Okay, we've finished cleaning the coolant system. We flushed it and ran it, flushed all of that out, so now it's empty. Put the plugs back in it. We did find, however, that and we kind of expected that air wouldn't be enough to cool the radiator, so the easiest way we found is to cool the radiator with water. We'll show that a little bit later, so we'll control the temperature with water. Also, over here, I'm not sure that I'm showing it, we put a thermometer, so I can see that thermometer is right on top of the hose, and I can see what temperature, or approximately what temperature we're getting. So what we're going to do is, per the instructions of this block seal, we're going to mix it in a gallon jug with, I think it said 3 quarts of water. Mix that up. We're going to pour it into the engine here. It actually says radiator, but that's for a car, so it'll go right into the engine here. We'll fill the engine up with water. Then we'll top off the radiator, seal it back up, and run it 20 minutes and make sure it gets up to 160. Okay, the instructions say to shake it up and put it in 3 quarts of hot water. We have a bucket of hot water here. So, actually I'm going to use a funnel for that because I don't quite trust myself. Okay, so we're going to shake that up a little bit and put that down in the engine, which, going in this pipe, it goes through the water pump and on into the engine. Now we'll fill this up with water until the engine is full, and we'll know that when it starts coming out the other side. full, so we'll hook this back together. And we'll fill up the other tube, fill up the tube on the other side to complete the fill of the radiator. Okay, we have it running with the block seal in it. You can see we have a temperature of not quite 100 right now. So we're watching that. And you can see the sort of rusty color coming up into the radiator, and in a little while the radiator is going to get pretty hot, and what we'll do is spray that with water. Okay, we're at 114. I'm not sure if the video will capture it, but it's really starting to steam now. It's doing its job. Okay, we're reading 143 on our little thermometer that's on the vinyl tubing, but almost 200 on the dash gauge, so I think the dash gauge is more accurate than our little external thermometer, so we're going to start cooling now. We've been spraying for a couple of minutes now. Let's go check the dash. Yeah, we were nearly 200. We've come down quite a bit now, so we're safe. We've kind of found a steady state here. We have the water spraying at kind of a constant rate, and that seems to keep the engine at a constant temperature. We're 17 minutes in now, and we're going to go for maybe 23 or so. We want to keep it, the range is 20 to 30 minutes, but we want to keep it to the low end of that, because in our case, some of this block seal is going to get into the oil, and that's going to go through the oil system, and we want to make sure, we want to minimize the possibility of sealing up some oil passages. So that's why we want to keep it to the minimum of the range. We've got the temperature down now. We're coming up on, we're 22 and a half minutes, so another half minute or so, we'll shut the engine off. Then we'll begin pumping out the oil real quickly and drain the engine. Well, we ran our 23 minutes, drained the coolant out. Now we turned the oil pump back on. It connects to the dipstick here, and the pump's over there on top of the battery, and we're pumping into the jug there just to get as much of the oil out. Once we get all of that out, then we let it set for a day and put water back in it, new oil, and see if the crack is sealed. We're going to leave this attached, leave the radiator attached until we know that the crack is sealed. Once we know that, then we'll put it all back like it was and run some clear water through it to make sure everything's out, and hopefully that will be done. Of course, when we pull the drain plugs and let the block sealer out of the engine and into the bilge, it drained out the hole in the boat in the back. We put a couple of 5-gallon buckets there so we could capture that. Didn't want to get down on the ground, and we can dispose of that properly now. Now all we have to do is wait 24 hours. Well, we let the patch set a little over 24 hours and then changed the oil 3 times, and it came out, the last time came out looking fairly good. So I think we have it sealed. Then after that, took all the oil out, filled it back up with water, and if none of that water leaked out, then we probably have a good patch. So let's go check that. Water was all the way up to about here, and it's not in there anymore, but it's still in this hose. You can see it in there. So I'm hoping that was just maybe some air that settled out of it, but the test is going to be to turn the pump on. The pump is connected to the dipstick hole here. So if we pump out just kind of a little bit of slurpy air, we'll find. If we pump out water, we're not fine. So I'm going to stick the hose here, turn on the pump, and we'll watch and see what comes out, if anything. So I'm going to say that was just settling air out of the water, because when it came out of the hose it kind of aerated, and if it went through the crack I would have quarts of water here now. So I think it's sealed. So what we're going to do now is turn the pump off, is connect it back up like it used to be. So we need to put this hose back to here, this hose back to here, and this hose back to here. I think, oh yes, and this hose back to right there. That's what we're going to work on now. I have these loosened now, so I'll take this one off. That's the last plug. So now we have our T removed. Don't have anything on these. So now we're at the point where we need to put the thermostat back in, and a new thermostat. So take out these two bolts right here, put in a new thermostat and gaskets. Bolts are loose, or almost loose. There. Again, take the sensor wires off so that we can get to it. Okay, I'll turn this upside down now. And there are 4 parts, take the old gasket out, 4 parts to replace. We have a little gasket that goes in first, then the thermostat on top of that, then this little diverter on top of that, and then the gasket. First the little round gasket goes in, then the thermostat, and then when this little piece of plastic goes in, thermostat seated there, it goes in. This is a little tip that I broke off here. It goes in with that tip there, but there is a little notch right here. That little notch goes in here, and that's how you get it lined up correctly. When the plastic piece is completely seated, line up the bump with this notch here, and when it's completely seated, it'll be touching the thermostat down here, but it will have a little bit of a raised right here. And I've already cleaned this surface off with a scraper. Plastic part, as I just showed, is raised a little bit, and it sits down in a groove right here, and so I scraped this groove out to make sure that it's clean so that it can accept the raised part of that plastic. So now we're ready to put the housing back. The last time I did this, I put the gasket down first, and I kind of got it misaligned. So this time I put both bolts in the housing and put the gasket on the housing piece I'm holding, and then put it down and get the bolts lined up, and that way the gasket, I know the bolts will be going through the gasket. So I've got the bolts started now. Everything in place. Reattach the sensor wires, and now we're ready to put these hoses back in place. That one goes back to that exhaust manifold. This one goes to the exhaust manifold on this side. I need to take this fitting out so I can put this one back where it was. That piece is out now. This is the one that goes down to the water pump. You might have noticed some string that appeared in the middle of the video and down here. some tape. We let this hose rub against this belt. We noticed it before it rubbed all the way through, taped it up so we could get through our testing, and then put a string to hold it back. I have a new hose to put on there now. So I have these 3 hoses back in place and the clamps tightened, but this is the one I wanted to replace. There is a small, hopefully the light can show, there's a small bolt there. It's a bracket I have to take off, and then another clamp at the bottom where it hooks onto the oil cooler. Well, like every other rubber hose I've taken off, it coming off wasn't in its plans of things to do today, so I just took a razor knife and slit it where it was stuck and kind of had to peel it off. So that one's done. I do want to make sure though that the one I bought is the right one. Kind of line it up, and yeah, it looks like it is the right one, so we'll put that on. Okay, got the new hose hooked on down at the bottom where it hooks on to the oil cooler. That was a bit of a challenge because it's underneath the motor. And by the way, you'll notice my bilge is not real clean. You should always clean your bilge. The reason is that when you drop your tools in a clean bilge, they come up clean and you don't get your hands dirty, at least not as dirty. So keep your bilge clean and you keep your tools clean. Tighten up this bracket right here. Well, there it is. Then we'll put this hose on here. So there we have the last one. When I put these clamps on, I always think about how am I going to access them if I have to take them off. I'm putting them on with a wrench, but I might have to take them off with a screwdriver in a pinch, so I always try to arrange these so that I have access to get. So now everything's back together. All I need to do is remove the oil pump from the dipstick hole and fill it with oil. I mentioned before, but I think I'll show it to you as I unscrew my pump from my oil dipstick hole, that this particular dipstick hole does have, or dipstick tube has threads here, so you can put it's basically a garden hose fitting, but it does have kind of a deep throat to it so that this can go up into it and it'll seal here, and that's how I'm able to pump out, because it's made with this thread on it. Dipstick goes back in here and put oil in it. For those interested, this is what my pump looks like. I had one for years. I bought it at Harbor Freight. It was cheap, but it lasted a pretty long time. I bought another one on Amazon and it didn't last but a few days. I bought this one on Amazon and it's held up pretty well. The only thing I had to do was I had to replace the input hose with a braided vinyl hose so that it wouldn't collapse under the pressure, or the suction rather. And then of course I had to put a garden hose fitting on the end. That's what that looks like. Well, the last thing to do before we fill it up with oil is we need to put a new oil filter in. The oil filter that's in the boat now, I did replace it before I started this process, but it's going to be full of that watery oil. Probably got stuck in there, and I'm not going to show how to do that, but the filter is over on this side down in the back. It's pretty easy to get to. Well, the oil doesn't look too bad, but that was sort of a sacrificial oil filter anyway. I knew I was going to replace it, but it looks like we did get most of the water, the oil that had water mixed with it, out. One thing I want to mention though, when I do this, I typically put a oil absorbent mat. They're mats that will absorb oil even when it's mixed with water. I keep that in the bilge, and that way when you spill a little oil doing this, when it comes off, quite a bit runs down the side. That mat in the bottom picks it up before it goes out the bilge hole, and keep it out of the environment. I use full synthetic in all my vehicles, but in particular my boat, because it's much better than regular oil, and a boat runs at such high RPM when I pull skiers and tubers that I feel it's good to have the extra protection. Okay, the radiator's back where it belongs, out of the boat. All the hoses are hooked up like they're supposed to be. We've got the water on the ears on the outdrive, ready to start it up and make sure everything runs right and that there are no leaks. And we'll let it run a little bit. Check it one more time to make sure that the oil is not clouded. Then take it to the water for a test drive. It's been running about 10 minutes now. Just wanted to make one final check to make sure the new thermostat was working. According to the dash temperature gauge, it looks good. Last thing we want to check, Sure that the oil is not milky, and you can just about not see the oil. It's so clear, so definitely is not milky. It looks okay.